situation, an atwood type situation with a light frictionless pulley. We have 2.1 kilograms on one side, 2 kilograms on the other. So we have a 21 Newton downward force here, a 20 Newton downward force here. Both of these calculated just by multiplying the mass in kilograms by the approximate acceleration of gravity using 10 meters per second squared. More precisely, you'd use 9.8, and numbers come out just a little different, but the same idea. So the net force, if counterclockwise is the positive direction, then the net force is 1 Newton, tending to move you in the clockwise direction. So we say the net force is negative 1 Newton. And that should be very clear from your experience in lab and everything else we've done. Okay, so the acceleration is going to be net force over mass. Well, you've got 2 kilograms of mass here, 2.1 here. They're all being accelerated together in the counterclockwise direction, so that this one is going up and that one's going down. In any case, your accelerations are going to be negative 1 Newton over 4.1 kilograms, and that is going to round off to negative 0.25 meters per second squared, meaning 2.5 meters per second squared where the system is accelerating in the counterclockwise direction. Now we want to find the tension. So to find the tension, we isolate one of the masses. It doesn't matter which one we isolate, but I chose to isolate the 2 kilograms just because maybe it's easier to work with 2 than 2.1. Okay, so we isolate the 2 kilogram mass, and now we look at the forces acting on it. Now the forces are the gravitational force downward and a tension force upward. As we said in class, a tension force in a single string or elastic object is the force that you get when you try to pull the ends apart, and it's the force that tries to pull the ends back together. Well, these two masses, the force of gravity in these two masses causes this string here to elongate a little bit, and it responds by moving back, by attempting to pull back, so that it pulls this mass in this direction and it pulls this mass in this direction. The ends try to get back together, try to get back to their original distance, and assuming you haven't deformed it too much. And I did comment that the nature of that force is really kind of electrostatic. You're moving the particles in the string a little further apart. The atomic interactions are basically electrostatic. You pull them a little further apart, and there's a electrostatic force that tends to pull them back together, and that's a little bit oversimplified, but that's kind of the idea. Pretty close to the right idea. Okay, so bottom line, this thing is going to experience a tension force that tends to pull it upward, where gravity is pulling it downward. You have this picture. So the net force on the 2 kilogram mass is going to be the tension force plus the gravitational force. Now if the upward direction is positive, then the net force in the vertical direction is going to be tension minus gravitational force. Both act in the vertical direction. So we then conclude, well, here's one expression for the net force. Another is that the net force is mass times acceleration. The acceleration being 0.25 meters per second squared upward. That is, this mass is being accelerated upward because the system is being accelerated in its negative direction, where counterclockwise is positive. This thing is going to be accelerated at 0.25 meters per second upward. Now, we just declared that upward is positive, so that the acceleration of this object will be plus 0.25 meters per second squared, not negative 2.5 meters per second squared. This negative 2.5 meters per second squared is an acceleration of the system relative to a positive direction being counterclockwise. If we choose upward as positive when we isolate this object, that is that acceleration will be positive. The acceleration of this object will be positive. So net force is 2 kilograms times 0.25 meters per second squared, which is 0.5 newtons. So that net force is tension minus gravitational force. Net force is 0.5 newtons. So that tension minus gravitational force is 0.5 newtons. And the tension then is gravitational force plus 0.5 newtons, which is 20.5 newtons. Gravitational force being 20 newtons, having a magnitude of 20 newtons. Okay, so that's the solution for the tension here, and I just comment that if that is the tension, then the net force on this object is negative 21 newtons down, 20.5 newtons up, a net of 0.5 newtons down. Now, it won't be exactly the same as this, but to the nearest, rounding off, it is 0.5 newtons down, okay? If you do this more precisely, you'll find that that this force here is a little less than 20.5 newtons, and you'll have a little less than 0.5 newtons net force accelerating this thing upward. And actually that comes from the fact that if I divide this by this, I get a little less than 0.25 meters per second squared. Okay. If I get this number precisely or more precisely, then we're going to get better agreement. The point though is, if you use the accurate acceleration to get the tension, then if the same tension occurs on this side, you will have the same magnitude of the acceleration here. So you can check that out.